Hello, and welcome. Today, we're going on an incredible adventure, a 2,400-year quest to find something so tiny you can't see it, but it makes up literally everything. We're talking about the atom. We're going to break this amazing history down step by step so you'll have a fantastic way to tell this story yourself.
It sounds a little like the beginning of a joke, right? But believe it or not, these two people and a lot of others, separated by thousands of years of history, all helped answer one of the biggest questions of all time. What is stuff actually made of?
So, here's our roadmap for the journey. We'll start way back with an ancient Greek idea, then jump to Dalton's first real scientific model. After that, we'll see how the electron and the nucleus were discovered, visit Bohr's cool planetary system, and finally, we'll end up with the modern quantum cloud. Let's do this!
Wow, this timeline really puts it all into perspective, doesn't it? Just look at that massive gap between the very first idea and the first proper scientific theory. Over 2,000 years. Our story starts way back in ancient Greece.
So, you might think our story begins in some high-tech laboratory, but nope. It starts in the mind of a philosopher with a brilliant guess, an idea that was almost totally lost to history for over 2,000 years.
And this is where the word atom actually comes from. A Greek philosopher named Democritus had this thought: what if you just kept cutting something in half, over and over again? Eventually, he figured, you'd get to a tiny particle that you just couldn't cut anymore. He called it atomos, which is just Greek for indivisible or uncuttable.
But here was the big problem for Democritus. The most famous philosopher around back then, Aristotle, thought that idea was nonsense. He argued that everything was made of just four basic things: earth, air, fire, and water. And because Aristotle was basically a superstar, his idea won. The concept of the atom, it was pretty much forgotten for centuries.
Okay, now let's hit the fast-forward button and jump over 2,000 years to 1808. An English teacher named John Dalton brings the atom roaring back. But this time, it's not just a guess. He's doing experiments. This is where the atom officially enters the world of science for real. What Dalton did was show that substances always break down into the same elements in the same amounts every single time. So he concluded that all matter had to be made of these tiny atoms, and that different elements, like gold or oxygen, had their own unique type of atom. This was a total game changer because it was based on actual evidence, not just thinking about it.
So for about the next 100 years, scientists pictured the atom as this tiny, solid, unbreakable ball, just like Dalton said. But that simple picture was about to get a whole lot more complicated, and way more interesting. Then, in 1897, a physicist named J.J. Thomson found something incredible. He discovered tiny, negatively charged particles inside the atom. How do you explain that? Well, he came up with what we call the chocolate chip cookie model. Just imagine the cookie dough is the whole atom, a big ball of positive charge, and the little chocolate chips are the tiny, negative electrons stuck inside it.
And here's the biggest takeaway. The atom was not indivisible after all. It actually had smaller parts. Thomson's discovery of the electron was the very first proof of this. It earned him a Nobel Prize and completely changed our story.
And the story keeps going, this time with one of Thomson's own students, an absolute genius named Ernest Rutherford. He decided he was going to test that chocolate chip cookie model, and what he found was going to change everything. Again.
So think about this. How would you prove something you can't even see is mostly empty space? Well, you shoot stuff at it. And that's exactly what Rutherford did in one of the most famous experiments in the history of science.
Okay, here's how it worked. He fired these tiny positive particles at a sheet of gold foil that was super thin. Now, based on the soft cookie model, he expected them all to just zip right through. And yeah, most of them did. But then something totally crazy happened. A few of them bounced almost straight back.
Rutherford himself captured just how shocking this was. He said it was as if you fired a tennis ball at a piece of paper and it came back and hit you. I mean, it just made no sense unless there was something incredibly small, dense, and solid in there that the particles were hitting.
And this led Rutherford to an absolutely amazing conclusion. The atom wasn't a solid cookie at all. It was mostly empty space with all the positive charge and almost all the weight packed into a tiny, dense center. He called it the nucleus. All right, so the picture is getting clearer now. We've got a positive nucleus in the middle and negative electrons somewhere on the outside.
But where are they? What are they doing? The next piece of our puzzle comes from another scientist, Niels Bohr.
In 1913, Bohr came up with a really elegant idea. He suggested that electrons don't just fly around randomly. Instead, they travel in specific fixed orbits, or energy levels, around that nucleus, kind of like planets orbiting the sun. This planetary model was a simple, powerful way to picture how an atom was put together.
For a little while, that planetary model seemed pretty perfect. It made sense. But as our science got better, we started to realize that the world of the atom is, well, it's much, much stranger than that. And this leads us to the modern model of the atom, where things get really weird.
You see, Werner Heisenberg discovered something that kind of breaks your brain. It's called the uncertainty principle. And what it says is that you can't know both the exact position of an electron and its exact speed at the same time. It's impossible. The more you know about one, the less you know about the other. So that means electrons can't be in neat little orbits after all.
And that brings us to how we see the atom today. Instead of those nice, clean orbits, electrons exist in what we call a cloud of probability. This cloud just shows us where an electron is likely to be at any given moment, but we never know its exact spot. So the atom isn't a tiny solar system. It's more like a fuzzy cloud of possibilities.
Okay, so we've gone from an unbreakable ball to a chocolate chip cookie to a mini solar system, and now to a fuzzy cloud. That's a wild ride. But why does any of this actually matter to us in our everyday lives?
Well, for one thing, it explains the beautiful colors you see in fireworks. When the atoms inside a firework get super hot, their electrons get excited and jump up to a higher energy level, just like in Bohr's model. But they can't stay up there. When they fall back down, they release that extra energy as a flash of light. And different kinds of atoms release different colors of light, creating that incredible show in the sky.
And so, our long search brings us right here. From a simple idea in a philosopher's head to a strange quantum reality that lights up our night sky. It's been an incredible scientific journey. And it all started with one guy, Democritus, who after more than 2 millennia turned out to be right. There really are atoms.